evening. This is Nikita, co-founder of Society for Space Education, Research and Development. I welcome you all for the Space Talk at SSERD, wherein we bring in professionals from various space backgrounds and let them talk to you all about their journey and whatever they are good at. And today here we have one of the renowned person, and we're so much connected to her as she's from India. And so let's welcome Dr. Parshati Patel. Hi, Dr. Parshati Patel. Good morning for you and good evening from everyone.
Good evening to everyone who is watching, and also good morning if you're tuning in from other parts of the world.
Thank you so much for accepting our invitation. And I'll read out a short bio of our speaker for the day. So, Dr. Parshati Patil is from Ahmedabad, and she went on to become an astrophysicist, science communicator, researcher, and an educator. Now she's based in London, London, Ontario, Canada. She is an educational outreach and communications specialist at the Institute of Earth and Space Exploration and an adjunct research professor in the Faculty of Education at Western University. She has a PhD in astronomy and planetary science and exploration from Western University. She's been communicating her passion for space science and technology with students and the public for more than 7 years in various capacities through outreach initiatives and programs at Western University and nearby places. She co-founded Women of Color in STEAMM. It's science, technology, engineering, arts, mathematics, and not just mathematics, also medicine. It was started in Canada in 2018. Now, since June 2019, Dr. Parshati has been part of Principal Scientific Advisors Consultative group of Government of India. That's so nice to know what you've been doing, what have you done, and what are what is your interest? It's really wonderful to know that you're doing so many things, Dr. Parshati. Thank you so much for accepting for joining. Dr. Parshati will be talking, or she's picked up the topic called as the stellar detective. She's gonna reveal why she picked up this topic, and she's gonna let you all know how did she start off her journey from Ahmedabad to Canada, and what is she doing, and what are her works that she's done. So let's explore what Dr. Parshati has done. Over to you, Dr. Parshati.
Thank you, Nikita. I'm so excited to be here. And as mentioned, I will talk about why I call myself a stellar detective, and I'll share slides with it so you guys can actually follow the beautiful pictures from
moment they're not able to hear.
I'll start from the beginning. That's totally fine. Okay.
Sorry.
No worries. That's totally fine. So thank you again for tuning in. So as I mentioned, as Nikita mentioned, I'm going to talk about the stellar detective. And the reason why I call myself a stellar detective is because when I was young, I used to watch a lot of detective shows, and I always loved how you solve a lot of mysteries, a lot of problems by using the tools that are available to you, the clues that you have, and bringing those together and try and solve a problem. And so science, in many ways, is exactly that. You look at a problem, you find clues, you find the tools that you have, you combine them together with your knowledge that you already have, and try and solve that mystery. So I will take you through the journey of how I came into understanding, how I was, what my journey was into astronomy. Let's start with kind of the start. How was it started? I'm planetarium there, so we were actually able to go to the Nehru Planetarium in Mumbai, and that was kind of my first, first view of the universe was through that planetarium. And when I was able to learn about stars, I actually had more questions after the show. And so when I asked my parents to, kind of tell me more about it, they bought me books. So, I had a huge collection of books as I was growing up, because every time I had a question, my parents would buy me more books. And those books really helped me get a view of what, people were trying to understand about the universe, what the mysteries were, what are the things that people are still trying to figure out. But it didn't really kick into being a career until I actually got my first small telescope. It was almost this size, and it was gifted to me by my aunt who lives here in Canada, and she came to visit India, and she brought me a small telescope. So for the first time, when I set it up on my terrace, and I looked at Jupiter, Saturn, Moon. This I thought was really cool. And I was like, this is what I want to do, because imagine thinking and looking up in the sky and thinking about what is going on is kind of something that's very, very different than what a lot of people do, at least around me at that time. So that's how I got inspired. But obviously I did my grade 12. I took sciences when I was in grade 12, and I did not really know where to go. There were a few places in India I could apply, but I was, trust me, not smart enough. I was not a straight A student. And so I knew that there was a very low chance of me getting into those places. So, I looked forward. So instead of just going from grade 12 into, an astronomy program, I actually started my undergraduate at MG Science Institute in Ahmedabad, which if you're from Ahmedabad, you would know this place very well. And I started in BSc Physics there. I did 2 years of physics, and then I moved to University of Toronto in Toronto, Ontario, Canada. And the reason why I moved, because they were offering a physics and an astronomy program together. So I was really excited about wanting to still have a physics background, but also have an additional astronomy background. And it took me around 4 years. So it took me 2 years of BSc Physics. I did not finish my bachelor's in India. I moved to Canada. I did 4 years of undergrad there. So that's kind of total 6 years of undergrad, which is a little longer than what people spend. However, I was okay, because I was enjoying all the courses I was taking, learning about different kinds of astronomy that existed. And I was very lucky that in my 4th year at University of Toronto, I was able to actually do research. So there was a course that you can take, which gives you 8 months of research experience. And when I looked at the planets through my telescope in India, I always was wondering, how did these planets form? I was really, into planets and stars rather than galaxies and cosmology, just because I felt more closer to them than, what galaxies and cosmology could. So I was lucky enough to actually be able to get some experience doing undergrad research. And obviously I picked something that I really liked was how planets formed. And this is an artist's image of, what would happen. You have a star, you have a lot of material around it that is going around. And you have a lot of these clumps that start to form. You can imagine dust sticking to each other and forming these small pebbles, and then from pebbles to become rocks, and rocks to become, bigger rocks and into planets and moons. And so I did computer modeling of these planets and how they form. In particular, I was looking at once the planet forms. So in this image, what you're seeing is what it would look like if you were to look at the system from the top. So if you were to go outside a solar system and kind of look down, this is what it would look like. And this is when the planet has almost formed right here. But what is happening is that there is still material around it. So what I was studying was how is this planet moving, respective to the star, is what I was studying. And I was, it was only 8 months, and I don't think I accomplished a lot in the 8 months. But it really gave me insight into what research looks like. I think I didn't really have any results to publish. I could hardly even get the code to run, but it gave me an insight on what research would look like. And I really, really enjoyed that particular aspect of it. So then I decided to move to University of Western Ontario, or Western University, which is now where I'm based. This is what it looks like. It's a really beautiful green campus. But the reason why I moved there was the fact that they had a very large group of people who actually studied disks. These are, material around massive stars, and there was a huge, I think there were 8 or 10 students who were studying in that particular area, and that really excited me. Another thing that was really exciting for me was to be in the astronomy, not only the astronomy program, but also in the planetary science and space exploration program, which was an add-on degree that you can do with some courses and some kind of research in that area. So I could, add more to what I already knew. And so I moved to for my master's. And for my master's, what I really studied was, you have a star and a disk around it. And depending on where you're looking at the disk, so all of these A, B, C, D right here are actually your viewpoints. When you look at the star, depending on where you look from, the light that you observe changes. And so we can just based on, for different elements, based on this light, we can figure out at what angle you are looking at the disk. And what's interesting is that you can actually model these, that if I were to look at from A, that is look at from the top, you would see this first panel, where if the disk is, disappearing, you can see a large hole is created. And if the same disk you are seeing anywhere between from B and C, you are seeing it something like this. And if you're looking through the disk, it would look, something that is looking like that, where you have a hole in the center as the disk kind of disappears. So that was only a 2 years master's project, but I've got really, really interested in the disk physics of it. And at this point, these disks weren't the disks that were going to make planets eventually. So I wanted to study something that made planets, because remember I said I loved planets when I was growing up, and I loved how they were forming. So I moved to a different research area in my PhD. And this is fascinating because hardly anyone had actually studied this research. It's in particular what I was studying. But let's look at kind of the background of it. So these are amazing star-forming regions. These are regions where you have the right kind of material for stars to form. And they look beautiful. They have a lot of gas and they have a lot of dust in it. As you can see, there are like winds that you can see that are blowing things away. Oops, sorry. And the most interesting part is that these regions are the ones that are going to create a lot of stars. And so what I was really interested in is the stars that are just forming, the very, very, very young stars, but the stars that actually have disks around them. Because I studied disks in my master's, it allowed me to understand all the disk physics I needed in order to figure out how these massive stars are forming. So all of these pictures you're seeing were taken by Hubble in the 90s in this star forming region called Orion Nebula. And each of these are young stars. And as you can see, they are all different. Some have these, tails around them. They are called jets. Some don't have those jets, and they just have this plain, simple disk, as you can see here, here. Some have clouds of material, blowing away from them. So, this was very interesting to me because, we really had the kinds of stars that formed behind this thick wall of dust. And so my mystery for the 4 years that I was studying was trying to figure out what these stars were doing. So this is a star, this is an artist's conception. What these stars were doing behind this thick wall of dust where eventually planets would form. So this is the disk where planets end up forming, millions and millions, billions of years later. And so, we cannot really see the star itself, but what we do get is light. And so if I were to slice this picture into half, this is what it would look like. So you have a star in the middle right here. Because it is so hot, the massive stars are super hot. And you would get like a region where there is no dust. You have dust that evaporates. It's just so hot, even for dust to exist. So you would have gas in the center right here. But then as you go further out, you can start getting these dust particles and then rock material that will eventually form planets. So it was very interesting to me that I wanted to study this region because everyone studied rocks and dust and how planets would eventually form. Not many people were studying this area. So I really wanted to understand that particular area and how that affects the star formation. And so I used, as I mentioned, as a detective, you're looking for tools and clues. So the way we looked at the tools was using telescopes. So this is the Canada-France-Hawaii telescope in Hawaii that I was able to use, and we were able to collect light. And what we do have, the only thing we have from these stars is light. And so what we do with those light is basically split them into spectrum. And depending on what electromagnetic radiation you're looking at, so I was looking at mostly visible light, which you all may have seen if you have looked at a rainbow, where you have the droplet of water that actually acts as a prism that splits the light. And so in telescopes we use, we don't have droplets of water, and so we have things like prism that actually split light into many colors. And so based on the kind of star you have, so let's look at an example. Based on the kind of star you have, so these are most massive stars out here. The least massive stars, our sun is somewhere here, G2 type, just above the G type right here with the cursor. And if you were to split that, visible light that you're seeing from these telescopes, you actually get these dark patches that you're seeing on the screen in these, different spectrum. And those are very much like fingerprints. So, when you look at detective shows, if they find a fingerprint on the car or the murder weapon, that is very much indicative and unique to one person. The same way, we have tons of these metals and elements around the stars that have very, very unique, these fingerprints, as we like to call it. And these can tell us what kind of material exists around them, what's the strength of the material, and how far they are, in the disk, things like that. And that actually allows us to think about how these stars are forming. So now I have from the telescopes. Now, what do I do with it? So I have another set of tool as a detective that I will use. So I have my understanding of physics. I have my observations. Now, thanks to computer technology, I can actually create a disk and a star in my computer. And so what I'm doing is I'm taking everything I know, I'm recreating the disk and the star of what I think it is in the sky right now. Okay, so the light that I've received, I'm going to try and recreate that in my computer and compare the two. So if I am not getting the exact same observations on my computers as I'm getting from the telescope, then I know that I'm missing something in my computer model. And so I would go back and forth and try and change it in ways to understand what is happening me to be able to get the computer model to be exactly the same as what I'm seeing in the sky with the light. So those are kind of, my tools of what I use. But you may think about, what does a normal day look like for an astronomer? And it's very different depending on who you talk to. But I've kind of summarized in this particular slide what are the different things someone might be doing on a daily basis. You start with things like computer models. You code, you create computer models. You have the observational data that you clean and extract. You analyze that data. You put it in your computer code. You read out what is happening. You try to understand. A lot of the time is actually gone in thinking. You write papers. You actually read other people's work because you want to use the latest understanding in physics or in whatever field you're working. So we spend a lot of time reading other people's work. And then obviously writing our own work is important because once you have something, you want to make sure you tell everyone else in the world about it. And then we also spend a lot of time in writing observing proposals. These are, remember I mentioned I had some time on a telescope in Canada, the Canada Hawaii telescope. You actually have to compete for it. You write a strong proposal of why they should give you time to look at this 1 or 2 or 3 or 100 stars. And then you compete with everyone around the world, and they give you a certain number of time for it. So you spend a lot of time writing why they should give you the time. And then last but not the least, you want to, in addition to writing papers, you want to communicate with other people. So attending conferences and showcasing your work is also a very, very important part of being an astronomer, or in general, being a scientist. This is very much, if you are in terms of not a lab scientist, this is generally what you would be doing in any sciences. But then I kind of transitioned into a science communicator. And the way that happened was during my PhD into doing research, I was doing a lot of communication. So I was going in classrooms like you see up here. I was doing a lot of public events. Oops, apologies. A lot of public events. I was talking to a lot of people about why space is awesome, why you should be excited about space, and I did it in multiple formats. I did it, in front of public, in classrooms, on social media, on traditional media like radio stations and things like that. And during the time, I realized that I absolutely loved, talking about space. And transitioned after my PhD into what science communication or science, psychomer, as people like to call it. I had amazing opportunities through that. I've done soapbox science, University of Oregon a couple of years ago. I've been able to, work with Dr. Dave Williams, who's a retired Canadian astronaut. He wrote a children's book, and I was lucky enough that he asked me to be a consultant on their book, and I was able to do that. I still talk to media a lot. I do social media a lot as well. But in my core job that I do right now, where I'm managing an outreach program, my job looks a little bit different, where I'm not only training teachers, I am working with students in the classroom. I'm developing programs where kids can learn about space, after-school summer programs. I go into undergraduate and graduate classrooms sometimes to talk about space. Here is an example of me from a couple of years ago, where I was in Gandhinagar when I was talking to a group of college students about space. And then I also get to do amazing public events where, we talk to public about different things about space depending on the time of the year. And also do podcasts where I interview a lot of different people, just, trying to learn what they are doing. And so you might be thinking again, like, how is the life of a science communicator different than an astronomer? It's actually very different in many ways, but also very similar. It has to do with, it's going backwards instead of forwards. It has to do a lot with developing and leading workshops, programs. You're organizing a lot of things, but you're also managing people. You are, working with social media. You're doing communications, promotions, and you're doing research. So believe it or not, I was lucky enough to be part of the Faculty of Education, where I now actually get to do research on how people consume consume science, how students feel about doing a certain activity. Is this changing their perspective about science? Is this changing their ideas and thoughts about if they see themselves in this field? So I do research in education field now, but it's related to space. What are people thinking about space? Whether it's young students who come to our events or our programs, or public who come to our events. So looking back at, are we doing a good job, but at the same time, is the program actually making any impact? Are they changing or thinking things differently? Are they excited about learning space? Are they amazed by learning about these facts that they did not know before, or just learning about what we do as in science on an everyday basis? So that's kind of my two different phases. I'm still in understand what all the sciences are happening, or all the astronomy is happening. But then on the flip side, I'm also communicating a lot of research that not only other people are doing, but also what me and my co-investigators or co-principal investigators are doing as well when it comes to education research. So I'm that I gave you guys kind of a brief overview of everything, kind of starting from my journey from Ahmedabad to Canada, and I would love to know if you guys have any questions that you have that you may want me to answer. I'll be more than happy to do that.
But they were able to hear a little bit breaking points. And yeah, so I request all the audience, in case if you have any questions, do comment down, and we're gonna pick up those questions and ask Parshati. And I have already collected a few questions, like as you all had registered earlier. So I'm going to start off with those questions, and Parshati can answer them. And meanwhile, if you have any questions, you could post down over there as well. So to start off, actually there were a lot of questions on how you started, and how did you how did you enter into the current stage, which you have actually explained everything by now. But then there is a question from one of the participants, wherein it said, uh, in what manner the physics is related to astronomy? I think this is the question which most of the students here have. Like, most of them think, okay, what is astronomy and what is astrophysics? Some like, what is the basic prerequisite for astronomy? This is a question from Parvata Vartini of 20 years old. Yeah.
Awesome. Thank you so much for the question. Yeah, so, there are a few things that I would want to highlight that will help them kind of understand why physics, what I did was kind of related to physics, but it doesn't always have to be physics. So space or astronomy is it's an umbrella of fields that you can study. We are in an age where you can study space law, space policy, space education, geography, geology, planetary geology. You have engineering, you have astronomy, core astrophysics or planetary dynamics kind of research. So all of these require different. So what I study, I call myself an astrophysicist because my core research was disk physics and trying to understand how stars form, and all of that comes from the basic laws of physics and the physics that is needed to understand. But doesn't really mean that I only use physics. There's a lot of math in it, as well as chemistry. There's a whole mixture of these subjects that I actually used when I was doing astrophysics. But you don't always have to have. I know a lot of people are scared of math and physics in many ways and think that is what you require to study space. I know students who are geography and geology that may not have taken physics in their life, and that is totally okay. You can be studying space law or space policy that definitely does not require physics. So it's not a prerequisite. However, if you are looking to study stars, planets, galaxies, cosmology, that has a lot of basics in physics, chemistry, and mathematics. I also want to point out one more topic. And a lot of people ask me is astrobiology. So that is studying life on Earth and beyond Earth that may or may not require physics. I feel like there's some physics that is required in it, but not as extensive as what I would do is solving equations on a daily basis when I was an astronomer.
Great. There's another connecting question, Parshati, that is what we can do as an Indian to become an astronomer, and what's the path that we have to follow?
Yeah, so if you want to kind of study what I did as an astronomer, study stars, planets, or galaxies or cosmology, you definitely want to make sure that you take physics, math, and if possible, chemistry. I know depending on where you are, your schooling, they may not allow you to choose many subjects, but I would say, those three would form your basis. If you're able to do that in high school and maybe in your undergrad, that is the first starting point. I know India has a lot of universities now that do offer masters and PhD, and some universities that offer bachelors as well. So I would suggest, look into those fields. But if you want to go into something that where you're studying planets, stars, galaxies, or the formation of universe, that's when you would really need basis of physics and math. So, what I started when I was doing my bachelor's in India was do physics and math, because I knew that I'm going to need that when I want to study stars and planets. So, you think about what you want to study and kind of backtrack from there, that what are the things that you are going to need.
Great. Again, it's really nice. There is one interesting question from Lerin Acharya, who's 31-year-old. He says, what is the career opportunity for a techie experienced in machine learning, AI, and IoT to join any space firm? Like, is there any way that they could connect these things to space science or astronomy, astrophysics?
Yes. That's a really, really great question. Thank you for that question. That is actually the new age astronomy. We call it like we are in an age where we have so much technology. We collect so much data on every nightly basis that we need people who do machine learning and to be able to process that data. And there are a lot of research that is happening currently on how to use that data effectively, teach the machine how to recognize, let's say if you're trying to observe or detect a planet, what kind of signatures does it need to detect in, I don't know, gigabytes or petabytes of data, and use that. And then once you have a detection, then you have a human interaction where, okay, now humans go in and check out if the data is valid or not. So there is a lot of opportunities for people who are in machine learning and AI in this field. I'm not sure if it's in a particularly space firm possibility, but there are a lot of research groups on universities and research institutes that definitely use machine learning. So if you're interested, look into these institutes that actually do research and try and connect with them.
Very nice. It's again like really nice to know that how the space industry or the space firm needs people from all the backgrounds, like literally all the backgrounds, right? So there's a question which says, can we get into NASA or any space agency just after completion of Bachelor's of Technology in Aerospace Engineering? If yes, how? Because Parshati, I would like to say this, that our Indian students here, sometimes they might not know the course that they're going to study in aerospace engineering. Most of them think that they would actually study about the planets and in fact the content of astrophysics. So they would have, by mistakenly or without knowing, they would have taken aerospace engineering, but their interest is astrophysics. What could they do at that point of time?
Yeah, so there is definitely multiple ways. There are different things. First of all, I think I would want to mention, because the question mentioned about space agencies. So one of the things that's very critical to remember is that, to be, let's say, part of an ISRO, you got to be an Indian. To be part of NASA, you need to be an American citizen. But there are ways to be able to research with them. So there are ways, like, for example, we have a lot of researchers here who have contracts with NASA or CSA, whereby they're still doing research. It's just that they're doing it at an institute rather than being at a space agency. So that is one aspect. The second aspect is, when you have done an engineering degree, generally a lot of people don't go on to master's or a PhD with an engineering degree. But there is definitely a possibility of you, if you want to get into research in, let's say, astrophysics, like Nikita mentioned, you can definitely do that because you have that basis in physics and math that you really need to be able to get into that. So you just need to find someone who would take you in as a master's student and you kind of switching into astronomy. I do know a lot of people, I actually know a professor who switched from engineering to astronomy, and there are multiple ways to do that as well. There is instrumentation. So astronomy instrumentation is you are building these instruments for the telescopes or the observatories, where then you'll be observing. So you'll still be doing some observing. You'll be calibrating those instruments. That requires engineering background as well as physics and math background, right? So you will be doing astronomy at the same time you'll be using your engineering skills. So there are tons of ways. And Nikita, you mentioned that space is so interdisciplinary, which is the amazing thing, because you can, take your expertise from one area and apply to another area so easily. All you really need is find a passionate person to do that with you, is, your supervisor or your boss, wherever you're working. Just combining the two is just, know your strengths and find ways to incorporate what you love.
That's a very nice way of getting into what you want, even if you have taken something by mistake. Nice to
Yeah.
know, but Stephen, like I didn't know that, so it's very nice, good information. In fact, thank you so much. There is one comment on Facebook by Amar Pal Singh which says, "Can we weigh the dark matter?"
Okay, so that's a really, really great question. So dark matter and dark energy, we know very little about them. We know they exist. We know they exist because of the way they interact with things. They don't emit light like what a lot of the planets and the stars, and so planets reflect light from the stars. Stars basically emit light, and galaxies are forming a whole bunch of stars, so they emit light as well. Dark matter, dark energy, they don't. So we know that they exist because of the way they affect things around them. We know how much material or how much of the percentage it is based on things like, if you were to calculate the speeds of stars as they go further away from the core of the galaxy, and what you see is it's not going down. And the reason for that is, these material that we don't really know much about, so we call them dark energy, dark matter. As far as in terms of weighing is how far we can say percentage wise what content there is. Other than that, it's not something like, like a planet or something like that we can say, here's the size, we can calculate mass, because that's, we use the basic mathematics and physics formulas to be able to calculate that. That is not something that what we do with dark matter and dark energy. Also, I'm not an expert on dark matter and dark energy. I'm very much of a star person in many ways. So yeah, from what I know, and what I understand, there is not something that we could do, but we can understand the percentage of material that we know is dark matter and dark energy. So I hope that answers in some format the question.
It does, it does. And we have to like really understand from person like you, because you know much better than us. So yeah. Another question is that how soon can a massive star go on to become a supernova once its hydrogen has been used up?
So that's a very, very good question. So massive stars. So for people who don't know, I think I'll point out that am I able to share my screen again? Is that okay?
Yes, you can share.
Okay, sure. Perfect. So I will actually, so I'll bring up this thing, and while I do that, I'll talk about why, why I think it's important to talk about the mass of the star. Depending, so to young stars. And so, what really happens, so once hydrogen is used up, you have, helium that is being built up, and it produces all of these heavy elements, as you can see in my cursor here. These are basically all the heavy elements that are forming a massive star. Okay, so for example, if we are, we have a 25 solar mass star, the hydrogen to helium fusion is around 10 to 6 years, 10 and then 6 years. As we go closer to higher, that be short. So if you were to count all of these, sometimes hundreds of thousands of years, depending on the mass. The more massive you are, the faster you are going to burn up with all of these and basically go into this, what we call core collapse. Basically, iron can no longer fuse into anything else, like how of the other elements, as you see in this picture here, silicon is fusing into iron, but at iron, you're just hitting a wall, because in order to fuse iron, you require a lot of energy. Instead of giving out energy, you are taking away energy. So what is happening is that core, basically within fractions of seconds, actually collapses. But to get to iron, it takes a long time to be able to do that. So, if I were to add this, it's basically 10 to the 10, 10 to the 11 years, even just to get to oxygen, then it's 6 months, and then 1 day. To basically get to core collapse. So, depending on the mass of the stars, this is just for a 25 solar mass. The bigger the mass, the faster this process will happen. The smaller the star, the slower the process would be. And sometimes it may not even reach to iron, depending on the mass of the star. So yeah, it's an interesting, complicated, but a very slow process for human time scale. If I'm
Very nice explanation, Parshati. There's one question. It goes like this. It's from Dilip Thakur, who's 39-year-old. He says, we have an astronomy club in our school. How can our students get your guidance on regular intervals? Like, there must be so many schools. You've been into communication and outreach. We have been into that. And if you could just tell everyone who is watching, how could they just start off with small, like in a very small lines with the outreach and education? If there's anything you would like to say, or if you could just comment on that, it would be great.
Yeah. So I mean, there are multiple ways. There are some amazing people. If you want to reach me, like, you just Google my name. But also, like, people like Nikita and Sujay, who are doing this amazing job, with this organization. Reach out to them. Reach out to a lot of astronomers are on Instagram and our Twitter. Just Google them and ask them questions. We people are more than happy to answer. So yeah, reach out to people who are really doing space education. For example, we have Nikita and Sujay. Reach out to them. Reach out to me. I'm happy to help as well. And in order to get started in something like this, I found my love, with books. I read a lot of books, so I would say, start with having a lot of books, have students read the books, discuss what they're reading. Nowadays, we also have a lot of technology, so use, the YouTube, which you're watching this video on right now, or use, other ways of trying to interact. We have a lot of apps that you can use as well. So I would suggest, find different ways of incorporating space. Could be through technology, or could be just storytelling or books, or reading books.
Very nice. Again, thank you so much, Mr. Thakur. in case if you need any kind of help in running the long run programs for your school, for the students at your club, do reach out to us. We will try to support you in any possible way. We do run such long run activities. We could tell you the list of activities that you could do. And since now you've asked Parshati, she suggested so many wonderful activities and you could follow up. And I hope that helped you. Thank you for the question, by the way. And Parshati, you are into outreach, and you were telling that you go to schools and teach, and when we talk about here in India about astronomy, something else gets connected. In fact, there was one question over here as well in the comment wherein it says, let me just read out. Just a second.
No worries.
I think it's all about like what would you comment on the astrology and the astronomy. Like this is like the most question, because I do go attend the TV shows particularly during eclipses, and I get to sit along with astrologers and have to answer them. But it would be really nice if you could just give them the difference between these two and how does each work with.
Yeah, so astronomy is studying the science, the physics and math behind how things work. These are stars, planets, all the phenomena like eclipses, transits, things like that, as well as how stars form, how galaxies form, how the universe formed. And that is very different than astrology, because astrology is mainly taking the constellations and kind of the planets that you see in the night sky and how close they are. And that is more talking about how it affects you as a person. Based on this that we know, we can actually, I say this a lot of the time, and I know a lot of people do dislike me for saying this, is the fact that, we know the science. I can calculate how much force is exerted on you from Moon or from Mars or from other planets that are close by, or you can see the night sky. And we know that force is very, very small compared to what you would say to, a mass of a body that's like an ocean or a sea. And so there is a distinct difference. In sciences, we go based on the evidence that we have. There is no way for us to connect how it affects your body. There's no way how to say that, because you're made of water, that the water in your body will be affected just like water in the ocean does. No, the amount is small compared to the large body of ocean. So we as scientists know from the evidence and from what we have learned, the physics that we know, the science that we know, that it does not affect us in any way. Astrology, the other way, is to guide you, in the ways how your future is affected, how you as a person are going to be on a certain day. I personally do not believe in astrology because of the fact of how much I have studied science and planets and stars, and I know the basic science does not work with astrology. But I know that I get this question every time I talk to someone in India. And I understand that there's a confusion between astronomy and astrology, but they're two separate things. They don't go with each other. As an astronomer, I have nothing to do with astrology. And it's the other way around too. Astrologers do not understand how stars form, how planets form, things like that. So keep them separate. I personally do not believe in astrology or how it affects me or anyone else on Earth. But I do not want to contest with the ideas that you have. This is my personal ideas, and this is just from the things that I've learned in science. So I'll leave it at that.
Thank you so much for answering that question, Parshati. There is, as I see the number of participants who are listening to your talk, or those who had shown interest in, listening to you, even now listening, most of them are like, they are into different backgrounds. Like few of them have already picked the pure science, and few of them are doing their bachelor's, few of them are doing their masters in pure science, and few are actually doing their engineering in both in masters and bachelor's. And then there is a common question that I see: what are the different jobs that they could find, like the career that they could find in the field of astronomy, astrophysics, like major options that they have with this as their background?
Yeah, so let me actually again share my screen. Sorry, I'm going back and forth, but I know all of these questions come because I do these a lot of the time. So I'm going to share my screen again, hopefully one more time about the career. So this is just a quick thing that I put together, and this is very much related to what I see and hear from people who I personally know. So as an astronomer, you could be working at a university or a space agency, government agency, doing research. So you could be a research staff member. You could be a professor at a university or a college. You could also be an astronomer working at an observatory. Now, there are less and less number of people working at the observatory because thanks to technology and innovation, we now have mostly computers doing the job. But there are still a couple astronomers per every observatory, at least in this part of the world. A lot of my friends, we in astronomy do a lot of data analysis. As I mentioned, and in life of an astronomer, you do tons of data analysis. So a lot of people move into industry where they work as a data scientist or a data analyst. Some people also, do research and development in industry. And that could be in any industry. It doesn't have to be like science or physics focused. It could be in biology, it could be, in life sciences, could be wide variety as well. One of the things that I have had a chance to do is science consulting. So, if people are looking for an expert, they reach out to you, like for books or for movies, or, you could be for YouTube videos, things like that. So that is also something a lot of people do. You are a good manager when you are doing astronomy as well, because when you do a PhD, you're managing a whole project for 4 years and you're responsible for that. So you're great at managing people, managing your research by yourself. So a lot of people go into management as well. Now, those are kind of the core ones that I've normally seen people, but there are other people who go into things like scientific or educational publishing. So you are basically an editor, you could be a writer, there are a lot of journalists who have studied space or science in general as well. You go into science communication like I do now, and if you're someone who loves law and policy, there are a lot of government agencies now hiring policy analysts who are basically looking into policies of, how things are going to work when you go to Mars, when you go to Moon, where you place your satellites, things like that. We also do a lot of software development. So a lot of people in astronomy, when they're doing their PhD, they're using a lot of different kinds of software. They're developing things like, that program that I showed you that was developed by my supervisor. And so you're a skilled software developer. And so people go into that after their master's or PhD or even bachelor's sometimes. You can go into industry, but at the same time, you can be a teacher, engineer. And then the last two that I have listed are some of the more newer ones. So you have, space law and patent attorney, because space law is now a new thing given the era of space industry being a lot more dominant in doing research and launching satellites than the government agencies. And then last but not the least, my most favorite, this could be meteorology, it could be climate science, because a lot of people I know here at Western and across Canada also study climate. And this can be climate here on Earth and interpreting that onto other planets, because a lot of planets or moons in our solar system have some kind of atmosphere, or you can look at atmospheres of exoplanets. These are planets outside our solar system. So these are just like, some. I wouldn't say these are all, but these are some of the major ones that I personally know people in these fields. And so I've kind of added them into a slide, because I know a lot of people do ask about this particular question.
listen to this video anytime later, what do you think are the most important skills that they must have or they should try to learn and have them with them to get into this field of space or astronomy or astrophysics or anything in STEM?
Mm-hmm. Really good question. Thank you, Nikita, for that question. I love this question because, it does not seem very it doesn't seem very often that what you will be using when you're doing astronomy or space in general. So I like this question because I'll highlight a few things that I think are very important. Okay, the first one is coding. We live in an era with laptops acting as these supercomputers, or when you connect to supercomputers. So coding is very important. I showed you guys a picture of this code that my supervisor wrote, which then I would use and add on to. And I did not realize how important coding skill was until I was at University of Toronto in my second year, when I had to take a coding course and I had no idea how that worked. And I ended up my entire PhD being a computational astrophysicist. That is all computing, that is all coding. So please, in this era, there's nothing that we could do without computers. Take time to learn coding, whether it's a simple thing like Python, which is a free open source that you can learn. Just go and Google and learn them. And I'm sure if you are going to be in this space, astronomy or engineering, you're definitely going to use coding. So that is my number one definite yes. And then number two, I would say problem solving skills. It doesn't matter where you are right now and what you're doing, as long as you have that skill and drive to solve a problem. It could be a mystery of the universe. It could be a crime for any reason, as long as you have that drive and know how to problem solve something, that is, I think, the second second most important skill that you would need in order to be part of this. So I think if I were to pick two, those two would be my coding skills, and problem solving skills are the two most important. The third one I would say is communicating, because if you want to talk about your work, you need to know how to communicate. So, those are the three things I would say are most important.
Thank you very much, and I hope all the youngsters who are watching who would like to take up career in space or in anything related to STEM have these three skills with you in your hand and try to learn as many things as possible, which will make you stand the first among many of them whom you would have with you, right? So that's something. And last but not the least, Parshati, how are you going through the COVID-19 scenario at your place over there? How are the situations there, and how have you been spending time during these days?
Yeah, so I am very thankful that a lot of my work has moved online. So obviously we had a lot of cancellation in our events and plans that we had for the summer. But we have been able to move things online, and I've been able to work from home. This is my home office that you are seeing. And then, I'm lucky enough to be able to still continue to do that. I've been spending a lot of my, other than my work time, actually talking to public, doing such sessions, making sure that I'm connecting to public in the time that I'm not working, but I'm still working as my core job, every day, 9 to 5, doing what I'm supposed to be doing. But then at the same time, connecting with my family, connecting with my friends, connecting with public who really want to know what space and astronomy is like.
Great, that's wonderful to know. It's like the line that you send at your free time, you're trying to communicate, as in you're trying to share your experiences or teach something. That's what I really loved. And thank you so much for joining us at this early morning for you and taking some part of your time and sharing wonderful information, like really important information among all the audience whom we have. And I surely hope that will be useful for them in their future time. Yeah, thank you so much. And if you would like to end with a message to everyone, you can. But thank you so much for joining.
Yeah, I do have one message for everyone. Just, something that I live by is be curious. Don't be afraid to ask questions. Okay, no questions are stupid. Ask questions, be curious, and explore the night sky and explore your environment. Is what I would say. That's my key message for you today.
Wow, wonderful, wonderful, like amazing. And these are the things which will make you again stand out of the rest of the crowd wherever you are. So try to be a person who would have all these thoughts of a curious mind. And thank you all for joining us. And thank you, Parshati, for joining again on this call on a space talk. This video will be available for everyone. Do subscribe, like, share, and just click a bell button so that you get to know any other space talks we have. We will surely we're actually trying to help you all by sharing or bringing new people who are actually doing a lot of things related to space and share their knowledge with all of us. So we need your support and the wishes. Thank you so much, everyone. Stay home, stay safe. Goodbye.
Thank you.